Now I have to look at D and E. As you can see, D and E are not equivalent. Therefore, this is not going to be possible, and it will be crossed out. So that's why you see it disappearing. Again, I repeat the sequence, and I have now my chart. So if you look at this, A is equivalent to B, A is equivalent to C, that's why I have them aligned, A or linked, A is equivalent to E, B is equivalent to E, and D is equivalent to F. So now I have to find the least number of states by finding cliques. So you can tell that I can have A, E, and B together, which means C is going to be left alone, and F and D can be combined together. As you can see, A, B, E, and D and F. C is going to be a lonely state on its own. It's not going to be combined with any other one. Okay? So that's why we started by this table, A, B, C, D, E, F, and we ended up with A, C, D. Okay? So state, when we say A, it is A and B and E in one state, so we combine them together. And when we say D, it is actually D and F together. And when we say C, it is the original C that we had already before in the table. And that's about it. What I would like to do before this, if you have 1 minute, I would like to do one question, if I can, on this computer, on the PLAs and the PALs. Do you have time? So yeah. Okay. PLAs and PALs. Just one question, just to show you how to program them. So the question here is, how can we use PLAs and PALs to construct combinational circuits? So you know, one of them has a programmable AND plane and programmable OR plane, and we just have to fuse the right lines to synthesize a certain product term. The other one has only the AND plane to be programmable, and the ORs are already there for us. We cannot do anything about them. Is that right? You remember this?
Yes.
So we have a function here given to us. This could be an exam question where you are asked to program a PLA. This is the one that has both and OR programmable, okay? So this is the function. You go and do the kernel map. You create the different product terms. So I did the kernel map here, and that gave me the expression for the first one and the expression for the second one. So now I determine the product terms that I need to program into the PLA, okay? So my first product term is going to be A, B prime. So I need to choose A, and I need to choose B prime. So I need to put a cross on A and B prime, which feeds into one AND to produce one product term. And I will do something similar to A and C, and so on. So as you can see, I have the A, B, and C. What I did here, I have A, and I have this guy here, which is B prime, and that gives me the first term. The other ones are intact, okay? Which means each one of these should be considered as one. Is that right? Because they are inputs to an AND gate, so just consider them to be cut here. That means they are floating at one, which means as if they don't exist. If you look at the second one, which is AC, so that's why you see A burned, and you see this guy here, which is C, and so on. So by choosing the right ones, by burning them, like putting the cross on a specific line of them, when you put a cross in our course notes, it's like creating a link or a fuse between the two. Just think of fuse there that you will activate if you would like that specific literal to be pronounced in the product term. Okay? So we have them. So we have three terms here. So I'll have to take the first one. I have the second one, because I'm producing the first F1. Okay, and then I have the third one, and I have the second one, because as you can see, this one has AC and this one has AC. So AC is used in both cases, and that's why you can see it here to be used in this one and in this one here too. When you choose not to fuse or to connect a certain line to the OR, consider that to be a 0. So an open link here is 0, an open link here is considered to be 1, just to make sure that the AND and the OR gate work properly. Okay? Yes. Question? Any question? Yes.
Could you go back to the previous slide? Yeah. You know how the F1 you have an inverter and a line going back in the end for F1 and F2, right?
Now this one here is the inverter is meant to mean in the construction of the circuit I can take this or I can take it inverted. That's what it means. It's not the feedback here.
Oh.
It's a fuse, which means I can take F1 or I can take F1 prime. That's what it means here.
But how can we tell? I mean, how can we tell it's a feedback with a loop that's going this direction?
When you learn the specifications of the PLA, it will tell you that that's the case. Okay? So you could consider it to be just F1 and you forget about the inverter. Because you can add an inverter yourself if you want later. Yeah.
On the exam, do we have to draw the diagrams in this detail, or can we use the method in the notes?
If you are to be given a question like this in the exam, I will give you the circuit like this. You just have to put the crosses in the right location, that's all. So I'm not going to ask you to draw the PLA. I will give it to you, you have to program it, that's all. Is that clear? Yes. That's all. No, you don't. No. Yeah, you just need the F1. This is just a general presentation. Okay, PALs. Where is my friend here?
How?
Okay, here we go. The question, PALs, the ORs are fixed for us. We can program the ANDs, okay? So let us assume that I give you a question like this. Implement these functions using the PAL, okay? So I have W, which is, I have the function here. From the min terms, I have it. I have X, I have Y, I have Z. So I have them here. Now I would like to produce them using PAL, okay? So you will have blocks of ANDs, just to show it to you. You see, remember, blocks of ANDs, you can program them, but you cannot program this. Okay? But remember, the ones that you don't set, they will be producing 0 implicitly because they are inputs to an OR. Okay? And that's what this one is saying. All fuses are intact, which means it will always produce 0 as a result. So there is one block which has ORs in it. There is another one that has ORs in it. There is another one that has ORs in it, and we have to program the ANDs, okay? So every